Today we're going to be talking about translations, and our learning target is I can translate a figure on a coordinate grid and write a translation using algebraic representation. I can use a symbolic representation to describe a translation. So let's talk about translations. A translation changes a figure's position and the size does not change. Okay, we're only moving around figures and shapes. We're not changing the size or anything. We still use the prime symbol, which is this little apostrophe, and it's placed after the letter to indicate that is the new location of the point. So similar to what we did Thursday and Friday. And then just like Thursday and Friday, there is another algebraic representation of a transformation, and it's just an algebraic way to show the changes in the x-coordinate and the y-coordinate. On Thursday, we found this algebraic translation like this, where here the translation was that we dilated x and y by a factor of 2, right? So today it's very similar, except we're looking at translations that are moving the figure left, right, up, and down. Okay, so since the axis runs right to left, let's put right to left here. An algebraic representation will show the changes to the x variable. Okay, so if the figure is moving to the right, then you're only gonna change the x, and you're gonna put x plus however many units you went to the right. If it's going to the left, then you're only looking at the x value because the only x's run from left to right. And since you're going left, you're going to minus the number of units that you're going left. Okay. So if you look at the y-axis, it runs up and down. And so since they are moving up and down, the algebraic representation will show changes to the y variable, not the x. It's only going to be the y. So if you see right here, if the translation is going up, then you're only adding to the y, however many units you went up. If you're going down, you're going to subtract the number of units that you're going down. Okay, so let's do a few examples. Let's see. We have draw a triangle ABC on the coordinate grid. So I'm going to draw the triangle. A is -4, 2. So right here. I'm going to put A. Always remember to label your points. B is -2, 5. So I'm going to put -2 up 5. And then C is 3, 2. Right, so I'm going to go ahead and connect those, make my triangle. And it says translate the triangle ABC 5 units to the right and 4 units down. So I can do this many ways. So I can get like point A, and I can go 1, 2, 3, 4, 5, and then down 4, 1, 2, 3, 4, and then this is where my point's gonna be, right? So right here at 1, -2. Oh, sorry, 1, -2, right? Because from A going to the right 4 and down, right 5 and down 4, that's where my new point is gonna be. So I'm gonna put A prime. I'm going to do the same thing for B. I'm going to go over to the right 5. So it's 1, 2, 3, 4, 5. And then down 4. 1, 2, 3, 4. It's right under that C. Okay, so here I'm going to put my B prime. I forgot the prime for the A. And then we're going to do the same thing for C. We're going to go over 5 units. 1, 2, 3, 4, 5. And then down 4. 1, 2, 3, 4. So right here at 8, -2. And that's going to be C prime. Okay, that's where I changed my location of my triangle. I didn't make it bigger. I didn't make it smaller. So I'm not going to be subtracting, right? So we're just adding and either adding or subtracting on our x and y axis. Okay, so let's go ahead and we said A prime was at 1, -2. B prime was at 3, 1, and C prime was at 8, -2. Okay, So that means for the x and y axis, from -4 to 1, we added 5. Okay, so I'm going to put that my x's, we're going to add 5. And you can test it on each one. From -2 plus 5, we get 3. 3 plus 5, we get 8. Right, so we added 5 to the x's. What about the y's? We get 2 to -2. That means we subtracted 4. Okay, 5 minus 4, we get 1. 2 minus 4, we get -2. Right, so here I'm going to put y minus 4. And that's going to be my algebraic representation. Okay, we have our regular xy because we always need to start with a regular xy. We have our arrow, then we have x plus 5, y minus, I think I put oh wait, no I didn't, minus 4. There we go. Okay, and if we look back in our notes, it does say if we go to the right, we're going to add our x's, and if we go down, we're going to subtract on our y, and that's what we did here. We added 5 on our x's, and we subtracted 4 on our y. Okay, so for the second one, we already have them, what is this, 1, 2, 3, 4, 5, 6. We have a 6-sided polygon, and it already has a and a prime. So did this figure translate from left to or right? So this is my original because it doesn't have the primes. These have the primes. So this is our original. And then this is my new, right? So let's see, just pick a point. I'm going to pick point A, and then I'm going to kind of like see how much did it go to the left, because it obviously went to the left, and how much did it go down. Okay, we went down, went to the left 1, 2, 3, 4, 5, so 5, and then 1, 2, 3, 4, 5, 6, 6. All right, so we did go to the left, and we saw that we went to the left 5 times, right? And the figure we went down 6, right? Same thing for all the other ones, right? For B, if we go over to the left 5 times, we went 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We went to the left 5 and down 6. Okay, so because we have those changes in our figure, and we slide it to the left and slide it down to the 6, we're going to have x comma y. It's going to change to x minus 5 because we went to the left, and y minus 6 because we went down. For the next one, just like the other one, we do have 2 triangles. We can see these have the primes, so this is our new, and this is our original, right? So from our new to original, we can see that it went to the left, and then it went up, right? But let's see how much they go to the left. Okay, so let's just do y. Okay, how much did they go to the left? 1, 2, 3, 4, 5, 6, 7. Oh, 7. Just 7 times, right? So it went to the left 7 times, and then it went up, because you can obviously see that it went up. How many times? 1, 2, 3, 4. 4 times. So our representation, our algebraic representation, will have our xy first, our arrow, and then we'll say x, it went to the left, so left is minus 7, and y, up is plus, so we're going to put plus 4. Okay. And then for the last example, we have this quadrilateral, and they give us the symbolic representation now. So it's saying we have an original xy, and we're changing it to this new one. Okay, so it says, will the figure be translated left or right? So remember, left and right is our x value. So here it says we're adding Adding is going to be going to the right. Okay, and if we want to look back, here we said if we're adding x's, we're going to the right. Okay, and by how much? We're adding 5, so we're going to the right 5. It says, will the figure be translated up or down? So now y equals, or y plus 3, we're adding, so we're going up. And how much? 3. Okay, so I'm just going to look at our points here. We have the pre-image, which is the original image. And then the image, which is the new one. And we already have A, B, C, D, which are already on the graph. I'm just going to add 5 to all the x's because that's what it says. And add 3 to the y's because that's what it says. That's what it says to do. Okay, so that's how I'm going to get my new points. A prime, -5 plus 5, that's 0. 2 plus 3, that's 5. So that's going to be where my new A prime is going to be. For B prime, 1, 5, that's 6, and 2 plus 3, that's 5. For C prime, 0 plus 5, that's 5. And -2 plus 3, that's a +1. Okay, and the last one, -6 plus 5, we get -1. And let's see, -2 plus 3, that is a +1. Okay, so I'm going to put -0, 5 right here. This is my A prime. 6, 5. This is my B prime. 5, 1. This is my C prime. And -1, 1 is my D prime. Let's go ahead and connect them. Okay, we didn't change the shape. We didn't change the size of the shape. We just changed the location, right? And so just to make sure, we should have gone up 5 and, right 5 and up 3. So from A, I'm just going to check it. 1, 2, 3, 4, 5, and 1, 2, 3. That's good. 1, 2, 3, 4, 5. 1, 2, 3. B prime is good. You see, so you don't always have to just graph it. You can just do your just the algebra of it, right? The adding of the 5 and the 3 on the x and y. Okay, so hopefully this helps. If you have any questions, please let me know.